Welcome to EDU World Space.
So in this video, we're going to talk about question 36 from chapter 20, which asks us to write a balanced equation describing the reaction of aluminum metal with concentrated aqueous sodium hydroxide. So when aluminum reacts with hydroxide ions, it actually forms, rather than an ionic compound, a complex ion, where we have AlOH4. And since we know that aluminum always takes a +3 oxidation state, our OH4 gives us a -1 charge overall. And then this negatively charged anion will form an ionic compound with our sodium ion. So that will be one of our products. So let's write out the full reaction and then balance it. So we have aluminum plus sodium hydroxide. And then since our sodium hydroxide is aqueous, we know that we also have H2O. And then the product we're going to form is our sodium, aluminum, OH4. So there we go. So we need to balance this. So for starters, we have an even number of hydrogen atoms in our products, but on our reactants, we have 2 hydrogen atoms from water and just 1 hydrogen atom from our sodium hydroxide. So we have an even number of hydrogen atoms in our products, but an odd number of hydrogen atoms in our reactants. So if we're going to have any hope of balancing this, what we need is a coefficient of 2 in front of our compound that's making our number of hydrogen atoms on our products odd. So we're going to put a 2 in front of our sodium hydroxide. And then because we have 2 sodium atoms in our reactants, we also need 2 sodium atoms in our products. So our complex ion on the right-hand side also gets a coefficient of 2, which gives us 2 aluminum atoms in our products. So we also need 2 aluminum atoms in our reactants. So we get a coefficient of 2 here as well. So now at this point, we have 2 sodium atoms, 2 aluminum atoms, and then we have 3 oxygen atoms on the left, but 4 oxygen atoms on the right. So again, we have an odd number of a certain atom on the left-hand side and an even number on the right. So we're going to need a coefficient of 2. So the molecule that's making our number of oxygen atoms in our reactants odd is the water molecule. So we're going to take 2 of those, since that will make us have an even number of oxygen atoms. So now we have 4 oxygen atoms on the left-hand side and 4 oxygen atoms on the right-hand side. What about our hydrogen atoms? That's the only thing we haven't totally balanced yet. So far we have 2 hydrogen atoms from our sodium hydroxide plus 4 hydrogen atoms from our water. That gives us 6 hydrogen atoms in our reactants. And then on the right-hand side, those 4 hydroxide ions give us 4 hydrogen atoms. So we have 2 fewer hydrogen atoms in our products than in our reactants. So to balance that, we're going to add hydrogen gas, H2. So now our equation is balanced. So the balanced equation is 2Al plus 2NaOH plus 2H2O forms 2NaAlOH4 plus H2.